Well, ladies and gentlemen, it's time for our next session. Efficient, low latency, high throughput LLM deployment for BFSIs. Now, may I introduce the next speaker? We have Mr. Sunil Patel, Senior Solutions Architect and Engineering, Nvidia. Please give me a big round of applause. We can do better. Let's go.
Thank you. Okay, so I saw a lot of questions on LLM in the last session. One gentleman was asking about how to build a custom one, so is there a saturation or not? So I think this is the right session for that kind of question. I'll start with, okay, I don't have clicker. Can you give me a clicker? Not working? Okay, no problem. Can you go to the next one? So Nvidia introduces the new way of computing, the parallel way of computing, and it's basically changed the way computing works, the way computing does things for us, right? And it's a backbone of what AI that you are seeing today in the world, and that has brought the new industrial revolution. So if I need to summarize Nvidia in just one slide, so that would be the next slide. Can you go to the next one? So this is what Nvidia looks like, a $4.5 trillion company in just one slide. We start with the silicon, which is the basic class, the bottommost layer. So a lot of people know us as a GPU company, right? Do you know Nvidia has world's most efficient CPU as well? Probably you might not know, right? But yeah, so we are a GPU, CPU, and story does not end at GPU and CPUs, right? You don't develop a LLM with just one GPU, just one CPU. You develop LLM with thousands of GPUs humming together at one frequency, crunching the data, and working as a team, and then develops that LLM, right? So we develop all the connectivity. And connectivity is not just like 10 Gbps, 25 Gbps, what you use regularly in your work, right? It's like data moved from here to here at 1.8 Tbps. That's actually the collective bandwidth of Netflix. I mean, if you want to transfer all the videos of Netflix from one core to another core or one GPU to another GPU, you would require 1.8 Tbps. So that's that's the bandwidth that is required to train LLMs, and that's something we innovate and we provide to customer, so that you can combine not just one, two GPUs, you can combine thousands of them at about 1.8 Tbps, and you will be able to develop or deploy your LLMs. For deploying LLMs, you won't require that much bandwidth, but yes, for larger ones, you will still require multiple GPU communications. Now looking at so we combine these chips and we create machines out of it. So there could be various use cases where you may end up using these GPUs. So there can be a inference use case where you just require one GPU. For example, if you're using a 7 billion parameter model, you just require one GPU with about 40 GB of VRAM. But let's say if you're using 70 billion parameter, you require two H100 with 80 GB because one H100 cannot accommodate that, right? And so connectivity is also essential. So for your inference workload, it could be 1, 2, 4, 8 GPU machine. For your training, it could be multiples of 8 GPU machines, right? So it's available. So these chips combine like, one CPU, multiple of GPUs, two CPUs, multiple of GPUs, and you can basically access them in any and every form factor possible as per your application. So it's available in a multiple form factor. A single GPU ranges from several thousand dollars to several hundreds of $1,000,000, right? A GPU can consume from about 80 or 70 watts to a tower, a rack that is capable of consuming about 500 kilowatt. Now those who are here from the data center domain, they can correlate, like we are currently talking about. So all the data centers, by the way, in the banks typically your machines are deployed are at max single rack is about 40 kilowatt, whereas we are talking about a machine that is single rack and it's 500 kilowatt. It's 10 times than the energy density that the current system provides. So that's what we innovate and that's what we empower the world. Like you can do your life's work in your lifetime. You won't have to wait for like 6 year, 10 year to have that simulation done. You will be able to do it with the power that we provide in a matter of minutes. And that's what I think BFSI also has realized. We work with all the large BFSIs, all the large banking companies in the world. We empower how they do computation in real time on Nvidia, right? So the thing that used to take about 4 5 hours, like fraud detection kind of mule detection use cases, that used to take like kind of 6 7 hours after the working hours. And by the time you found a mule or a fraud, that money had already gone out of the system. Now we are able to do the same thing at about 250 million nodes in real time while you do the transaction. So that's a level of impact that Nvidia provides to each and every transaction with UPI that we do. And it's just not hardware. I mean, if you have if you have fairly like $20 billion in your account, you can just go to TSMC and you can get a GPU out of it, right? You can build your own GPU. But the game does not end at the hardware. We have built our software for last 30 years. And it takes that much of time to mature that software. So that level of maturity now provides each and every data scientist, each and every business person a certainty that, let's say I want to accelerate that particular LLM on my GPU, I will be able to do it. That software supports it. If any new LLM is invented, it's invented on Nvidia GPU and it will run seamlessly on Nvidia GPU. So that's a level of software compatibility that we provide. Nvidia writes more code than most of the major software company combined, because our code is on a parallel architecture. We cannot just take a binary tree related code from GitHub and we can just parallelize on a GPU. We need to rewrite that code, right? We need to rewrite each and every code. The way the math kernel library works on your CPU, when you do 1 + 1 is equal to 2 and the way transistor work together and provides you the answer, it does not work that way in GPU. You require a parallel, you need to consider the parallel architecture into consideration. And for a data scientist, I mean, you don't need to write these kernel level codes because we have written about 1,000+ libraries right now. So if you need to do 1 + 1 = 2, you don't need to write that, CUDA level code. You will just be able to do with Python. But more importantly, if you want to do millions of 1 + 1, a matrix of million cross million plus a matrix of million cross million elements, if you want to do it in parallel, still you will be able to do with the same flexibility, and that's what we empower with the libraries that we have built throughout our 30 years of existence, right? So that's what Nvidia brings on the table. So on the software side, we have developed something called Compute Unified Device Architecture. I'll cover fair detail about CUDA towards the end, but in one sentence, that your developer is currently working on a laptop, has the same level of flexibility of writing the deep learning code or running a small LLM on a laptop. If the developer copy and paste the same code on a workstation with 4 GPU or on a data center with thousands of GPU, with just few line of configuration change, the same software is bound to run the same way, and that's what CUDA brings, the power of unified architecture across, right? We have many other drivers, just like Docker is very essential for networking. Like you require compute, you also require connectivity. Like let's say there are 1,000 GPUs and training LLMs, a gradient from one GPU need to be passed to GPU number 799. How the traversal happens, right, inside the network at 800 Gbps to 1.8 Tbps. That traversal is also optimized on what path it would take if the particular wire is not available or that particular port is not functional, what is the alternate route it will take. So everything is done at a driver level. You as a developer will not have to take decisions on this. Again, if you wish to go into that level of detail, Nvidia offers the entire platform as an open source platform. Happy to say that all the libraries, 99% of them are open source. So if you wish to go to the first layer where you just want to develop at Python level, you can do that. If you want to just go to the implementation level, which is C++, you can do that. If you want to change the level of kernel implementation at CUDA, you can do that. And if you want to further optimize at the level of how networking works and how kernel intercalling happens, that also you can basically go to that level of code and you can optimize that. So fairly open platform that we have built throughout the years. Next, please. Yeah, please click. Next. And as I speak, next. As I speak, we are not new in the FSI domain, okay? FSI is our good friend since CUDA existed. So since 2006 when CUDA was launched, a lot of companies in the East Coast realized that this is the best platform to be used for high performance trading and high performance trading research. So they started using it. They are the biggest user as we speak. Some of the companies are like, one company is giving a business of about $1 billion to Nvidia, right? So there's company like, that giant company exists for us in that domain. Then TensorFlow came, then PayPal and American Express and others started using deep learning for fraud detection and mule detection. Then we realized that a lot of FSI developers are actually using a lot of analytical tools like pandas, right? How many of you are using pandas? Lot of developers use pandas, right? Lot of developers use sklearns in your routine life. But when it goes to large amount of data, because these platforms are running on a CPU, they are not able to scale. So we realized that problem. We wrote a perfect parallel implementation of how pandas work or sklearn works on a GPU, right? So that the same code that you write currently with pandas is now accelerated on a GPU. And you will be surprised that what acceleration you can get. Okay, for example, if you are using pandas, if you are doing a find operation, you have 1 million rows and you have 10 cores. And if you say find some name for me out of these database, so all the 10 core will divide 1 million rows and will start searching for that particular name, right? And that's how the CPU computation work. Now GPU has 10,000, 20,000 cores in a single chiplet, right? So the same work it will be divided by 20,000 cores, you can imagine the performance that throughput that you will get out of that. So easily you on pandas, just by changing one line of code, you will get about 100x kind of a performance. That we have seen. It's not a marketing statement. Just go and read about cuDF, which is the library, which is a replacement to pandas, and just change one line of code in your existing code, you'll realize that performance, right? So that's possible. We have similarly written replacement to sklearn. So those who are using legacy codes of XGBoost or linear regression or k nearest neighbor, you just go and see how by changing one line of code you'll get that kind of acceleration. So that's what is Rapids. And Rapids basically helped a lot of companies to realize great potential and real-time computation over when the transactions are happening. We have also worked with HDFC. They could really scale their operations over 20 regions, doing the same fraud detection, which used to take about 6 hours to 6 seconds or and they could scale it to 20 regions. We are currently working with NPCI. You will come to know, what we have worked with them. That announcement is still to happen. So I'll not basically go to that. But we are deeply engaged with NPCI with what mule detection or AML or LLM side of it. Next, please. Okay, so where we can use GPUs specifically in the FSI, right? So starting with enterprise search, a lot of customers says to me that, I have a lot of document. When a customer comes to me, I want to make some strategic decision, but those decisions are always dependent on somebody providing a kind of information to me after querying some documents, after reading some documents. And by the time I get that analysis, the time is up. I mean, customer is gone, customer has changed the interest, and I basically lose a customer, right? So document enterprise search is one of the biggest, need that I see from all the banks in India. People want to just dump their documents to a RAG system, use LLM, and basically want to get answers in real time, like what is the net worth of this person, what is the capability of this company, how is the viability of this company, what loans should I offer to this company. So these kind of questions they want to basically ask to this LLM, and LLM has the LLM has to go to thousands of documents in real time and basically use LLM and basically provide you with the reasoning. The second one that I see is AML and KYC. We are a very innovative company, and a lot of innovation happens also on the wrong side of it. So with great scale comes with a great responsibility, and we see very innovative people, and so we use LLMs, and so we use real time fraud detection, mule detection, and all the capabilities with GPU. We see a lot of customers asking for the same. The third one is the biggest one. Because GPUs are so parallel, you can run the same Monte Carlo, the same Bayesian analysis and all these things in real time using thousands of core. So the person who is supposed to buy or sell kind of a call within a fraction of second, they are able to make these calls now with much confidence, because the same LLM goes through all the document of the company, of the stock which is of interest. It goes through all the put and sell and all the kind of behavior that the customers are currently doing as we speak. And it basically helps from all the way around, that how you basically use AI and AI and other techniques to basically arrive at the decision. So HPC is biggest consumer of GPU and algorithmic trading as well. A lot of companies use it for wealth management, document management. So these are all the use cases that we see in FSI as we speak. Next, please. Okay, so these are the three pillars I would categorize where people are working with Nvidia or leveraging Nvidia's hardware and software ecosystem into their work. So the first one is on the deep learning side. If you are a developer, if you are working with PyTorch or TensorFlow or JAX or NumPy, you can really accelerate your work on a GPU by just changing one flag, that to device GPU. That easy it is. If you are let's say you have thousands of lines of code in a TensorFlow doing fraud analytics, you don't require to do much. Just go to your code, just change the device type equal to GPU, and everything start running on a GPU. Now that's not a magic, because some of my colleagues work at Google, work out of Google Office and work out of Meta Office, and they make sure that the new version of TensorFlow or PyTorch comes. It comes with it comes with all the power that provides you just one line of code change and everything runs on a GPU. So we write all these kernel in backend and we ship it with the version of TensorFlow and PyTorch that you see, right? If you are working with NumPy, you can use CuPy numeric, which is a library which is a replacement of NumPy. You can just change the import, like you import NumPy as NP, right? You just change the import as import CuPy as NP, and most of your code will start running on the GPU. So that's the power of replacement. Second one is Nemo, and that's where a lot of companies I currently work with are using Nemo. Nemo is basically a platform. I'll go in detail of I'll discuss about Nemo in the next slide. But Nemo is everything to do with LLMs and NLP. So if you want to customize any model, if you want to build your new LLM, or if you want to use the existing LLM, as it is accelerated, so you use Nemo ecosystem, right? And the third one is very important for the data science and the machine learning, developers. You have any legacy code in a Pandas or Scikit-learn or NetworkX, right? You want to accelerate it, go to Rapids. These are all open source libraries, platform. It's not a product. You will build your own product by using this component, and you will be owner of this product. It's your IP. Next, please. So let's discuss a bit about Nemo, and I've given some preference to Nemo because in current time I see a lot of questions on LLM. A lot of people tell me that LLMs are not scalable. I'm not getting a return on investment, but I just wanted to break that myth, and that's why I'm going in little bit on Nemo. So Nemo is a platform that provides you multiple libraries for curation. Let's say you are a company, you have data, but you don't have that much of data that can basically help you to customize LLM for your company. So Nemo Curator is one of the sub-library that will help you to curate data, and basically then curated data will help you to train your own LLM. So Nemo Curator is an intelligent pipeline that also use a large LLM that has a better nuance about things, and then that will basically help you to artificially generate your data, and then you will be able to use that to further train your LLMs. Now Nemo Customizer we have built with a reason that uh, we will not have developers who will basically customize thousands of line of code in the LLMs, right? So let's say if you want to just do a small change in your LLM by using parameter efficient fine tuning, so that is supported. If you say that I just want to go above parameter efficient fine tuning because that has limitations, so you can go for supervised fine tuning SFT, or you can go for continuous pre-training, or you can go for training the entire LLM by yourself. Let me know if you are doing that. Uh, so everything can be done with the help of Nemo Customizer, and it offers you a low code, no code platform. That's where you can go and basically you can change some of the things. You can provide your data, you can choose a model and provide thousands of GPUs, and then it will work for you. I will take question at the end, okay? Uh, then you have evaluator, because when you train something, when you develop something new, you require evaluation, right? So evaluator will help you to continuously evaluate your LLM on a given parameter. Nemo retriever. So often I see that I'm using RAG pipeline, I'm using good LLM, I'm using vectorizer, I'm using a vector store. I'm not getting performance. My LLM just give me 10 words in 1 minute. Right? So a lot of component level optimizations are also required, because when you use a vector database and when you do some search over vector database, so literally it's a cosine similarity matrix and one to all, right? It's a n square problem. So if you want to parallelize that as well, you can bring the entire vector search on a GPU. So that way you have LLM on a GPU, you have a vector search on a GPU. So first the vector search is happening, you have 5 documents. You don't need to transfer those 5 documents back and forth here like IO from GPU and CPU and RAM. It just same document stays there in your GPU, just a pointer transfer to LLM, and LLM will be able to use those. So everything we have tried to bring all the entire pipeline of RAG on a GPU so that you will have a minimum IO and highest performance as possible. And then comes guardrail. I mean, everyone use guardrail, right? What you want is guardrail. I mean, it will help you to get precise answer. If the answer is not precise, it will deny you, but it will not give something misleading. And then Nvidia name as another animal by itself. I tell because okay, let's go to the next and then we'll discuss. So what is the advantage of Nvidia NIM platform? Nvidia Inference Microservices. So the thing that the bar chart that you see in the maroon is what the performance, 1x performance that you get when you download something from Hugging Face. Like Llama you download from Hugging Face and you straightforward put it to a generation request, you will get 1x performance, okay? And then when we optimize it with on the same GPU, okay, you will get about 5.1x, 4.3x or 8.9x kind of a performance. Same GPU, same accuracy, little bit higher power utilization or maybe max utilization, okay, and you get this kind of performance. Now companies who use model right out of Hugging Face, and if they don't realize the ROI, this is the right option to go for, right? Because you are getting 8.9x performance, that means you have increased your ROI by 8.9x, right? So this is the secret recipe that I am going to share, how you can achieve it. It is available out of the box also. If you want to spend your developer hours, it is available there as well. But this is something that we do. We use the same model from Hugging Face, we optimize it, we provide it to you, okay, or your developer can basically follow the same recipe and you will have that acceleration, right? So instead of 10 or 10 or 100 tokens per second, you will get 1000 tokens per second. Next, please. Yeah, so there are two ways you can do that. First one is, I'll go to the second one because I'm developer. So do it yourself. That would take about 1 week of time. You require hardcore developer at your place. Just go to Hugging Face, download a model, and then it takes about a process of 1 week. There's a library called TensorRT LLM. It's an open source library. Your developer will go there and optimize the model, containerize the model, stabilize the model, do the security testing, and basically put it to inference and monitor it and support it, right? So that's the second option. There is another option is Nvidia inference microservices, and I've seen BFSI are happily going to the first option because Nvidia provides containers already built, security tested, supported, and support is the thing that values more for FSIs, right? So that's the first option. It just takes about 5 minutes of your work, and then you will be having the same level of API what you use from API providers available to you on your premise in complete control of you, and you can basically customize it as well. Next, please. So this is the repository that I was talking about. You can exercise either of the option, but here is the option second for you. If you want to do it by yourself, just visit this GitHub repo. It's built, it's matured across 9 to 10 years in Nvidia, and right now it's at the peak maturity, so it will provide you the best acceleration possible. And it is, LLM did not existed for 10 years, but yes, we had TensorRT for all the deep learning models, machine learning models, and we have developed this library for about 10 years now. Next, please. Okay, and the first option is you go to build.nvidia.com. You search about your favorite Llama, Mistral of any size. You will get all the containerized microservices available to you. It just takes 2 or 3 lines of code. The model will be downloaded on your GPU in your premise. It could be cloud, it could be or your own machine in your premise, and will provide you the API. And that API you'll be consuming just like any OpenAI, Grok, or any other API. So that you'll have a complete control, and you'll never be bounded by number of tokens that you are throwing. So you'll not be counting that mental math of if I'll throw 1 million token, that I'll be charged so much. So that math is already gone. Next, please. Okay, and this is the beauty of Nvidia inference microservice. So otherwise, if your developer is doing, they have to install CUDA, they have to install Kubernetes, they have to install all the customization layer, they have to install n number of libraries, which you can do. It's available, it's not a secret. But this is something you'll have to do it. With Nvidia inference microservices, we have provided this with security testing and everything. So it's up to you what option you want to exercise, and you can basically go forward with that. Next one, please. Okay, and this is how the API looks like. So let's say you are using NIM, or if you are building by your own, so that will ultimately provide you an API that you can wrap it up with your OpenAI API. OpenAI API and ChatGPT and OpenAI, don't confuse it. OpenAI API is just a technology like HTTP service that you can create out of your local services, and that will behave like a LLM endpoint. So you will have slash chat and slash chat completion kind of endpoints available to you. So in your existing code where you're using cloud-based services, from cloud you are taking token-based services, you just go and replace that particular line with your local line, and that's it. Once you replace it, it will work as you want, right? And you are no more bounded by the number of tokens that you are consuming. So that level of flexibility is also there in the platform. Okay, and we come to the, we are basically providing you more flexibility. For example, let's say you deployed a Llama 38B and your HR team has separate requirement, your business team has a separate requirement, and your other teams have a separate requirement. Fortunately, you had data available. You customize these, Llama with some LoRa kind of adapters. So what you can do is you can centrally host that model, and you can have multiple of these LoRa adapter for HR, for finance, for other, businesses like infra. You will have separate adapters. These adapters will be activated as and when a particular person, for example, from infra, somebody is throwing a request. Now that particular request will be routed through an infra adapter. So infra person will get an answer that a infra require. HR will get an answer that HR require. So one model hosted centrally and multiple adapters around it. It will customize as your different departments require, the answer. So these level of flexibility is also there, and end-to-end it's accelerated on GPU. So you will get that ROI and the acceleration that is required. Next, please. And this is generational leapfrog. So for example, let's say you started journey with Nvidia 3 or 4 years before. You have A100 GPUs. That A100 GPU on Llama 3.37B provides about 1512 tokens per second, right? Uh, now so you had this GPU. Now you upgraded it to H100 GPUs. You got 3 times more token, 4 times more token. You upgraded it to B200, which is the current platform. You got almost about 8x more tokens, right? That calls for a promotion. So once you are on a GPU platform, the CUDA helps you to have compute unified architecture, so that the same code you can copy paste onto the new platform, okay, and you are going to get that acceleration, okay. So this is the acceleration across 3 generations of GPU, and you will get that acceleration. Next, please. Okay, this is what it is required. A developer with access to GPU, could be laptop, could be a small machine, right? So you write that code at a smallest possible level with the smallest possible data, test it out whether it works or not, copy and paste the same code on a workstation, on cloud like GCP or AWS, everywhere GPUs are present. So you copy paste the same code at different places where you want to scale out. Now it depends on you if you want to use 2 GPUs, 4 GPUs, 1000 GPUs, right? So that code will work with the smallest amount of change on any kind of cluster. That's CUDA, Compute Unified Device Architecture. Now your developer will have flexibility to write code in Python, C++, or if you want to do some experimentation, you can write it in MATLAB. Let's say if you are a high performance trading customer and you have legacy code in C++, you don't want to change the entire tens of thousands of line of code. So you have a flexibility to use OpenACC and OpenMP. These are basically directive languages. So let's say there is a for loop and you want to parallelize that for loop over number of cores. You just write that # for loop parallelize. And then you don't need to change the 1000 line of code, but you just annotate that where I want to use GPU for parallelization. And those number of code lines will get migrated to GPU. Typically 4 lines takes more time in computational execution, right? So these lines will be executed on GPU and your overall code will be accelerated. Still you want peak performance, like people at DeepSeek they utilized peak performance by using Nvidia CUDA, the way you basically implement kernels. So if you want to do that, you can go to kernel level libraries and you can basically get that performance also increased beyond the level, right? So that flexibility is also there. Next, please. Thank you very much. I hope that was useful. Yeah, please, you had a question. Okay. Okay. Okay, so NVIDIA GPUs, I mean, they stay relevant for a quite large period of time. So A100 is the GPU we released in 2020. Still people are using it and they deploy LLM on A100. So GPUs has a very relevant large time you can use that. So we won't say that suddenly that we have released a new GPU and that GPU is irrelevant. Typically we see that today we are working with a Blackwell generation. People still use A1 and Ampere generation, which is 2 generation down, right? So we will not deprecate that fast. Second thing is you will have LLM comings at any size, like trillion parametered LLMs are there. So typically one GPU is not going to be sufficient, but a distilled version of the same like 8 billion parameters, 7 billion parameters are also available. So you can use that. Now LLMs have already surpassed the human level intelligence. It can answer basically anything and everything. It can solve the calculus problem behalf of you, right? So it has basically surpassed that problem, but it is now venturing into the other modalities like videos or images and other stuff. You can even solve molecular problem with the help of LLMs. But when you look at general textual reasoning part, it has gone fairly, ahead of our understanding. Yeah, please.
So, firstly, thank you for that presentation. It was very holistic. As a student itself, I learned a lot. My question is, what's next for Nvidia, especially considering the Indian market and the change that we're seeing with government investing so much in India AI mission and a lot of research that was particularly with the high techs that you talk, like CUDA level programming and so on.
So we are working with government on many fronts. We are obviously working with India AI mission, and government is also supportive, and we are working with how to, educate top tier colleges on. We have been running this program for 10 plus years, but we are doubling down on how we can help government, how we can help colleges. We have already active programs in colleges. So yes, there is a momentum, and we are working with government. And what next in NVIDIA is something that Jensen can tell. I cannot tell. Just stay tuned to GTC, and you will come to know.
We am interested about the implementation of annotations that you talked about. So how do you take care of context switching when you give control from a CPU and then you parallelize that some part of a program into GPU? How do you take, is that a kernel level implementation?
Yeah, so a lot of these things we have automated. It's a kernel level implementation that takes care of the synchronization as well. Yeah, please go ahead.
So it's a very high level question. So right now, any business who want to use LLM, they have two options, right? One, either they go with the Gemini OpenAI APIs, or they decide to use their own GPU. So what are the absolute differentiators when the user should go the hosting the LLM on their own?
Okay, so it's a capex and opex game. Okay, so when you decide that I want to have my own GPU at my home, that is going to be capex investment. Like you are spending on a hardware, you are spending on a machine, you are going to incrementally spend on electricity. So you need to see, where there will be a, break-even point. So it's a capex and opex decision. A lot of big companies really invest in a capex decision. A lot of startups and small companies really like to go for a opex because when you don't have certainty, you really like to play really safe, right? So it's up to you. I mean, both the places GPUs are available. OpenAI is a great partner to us. So we won't discourage you to go to OpenAI, right? But it's again a capex and a opex decision, and it's up to you. I mean, what do you see in your business and how you want to take risk on that? Yeah, please.
I mean, there is a path in between, like you can use the cloud provider. So the Nvidia
No, we as Nvidia, we don't offer any services or product or APIs. No, we don't.
So you have tie-up with any cloud providers?
Oh yeah, I mean, we are available everywhere. So you go to Amazon, Google, even OpenAI.
Specific services which integrate closely with the NVIDIA SDK that you present.
Yeah, so you can go to Amazon. Let's say you go to Amazon, you want to use a specific, name out of it, NVIDIA Inference Microservice. So when you go to Amazon machine images, AMIs, you'll be able to find these AMIs available, and you will be able to readily.
You to host on the EC2 and
Yes, 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 yes. We don't provide it directly. Okay, thank you very much.